35 years, 13 billion miles. It began in 1972 when the project started in July of 1972, with launching 2 spacecraft in 1977 for Jupiter, Saturn, Uranus, and Neptune. NASA's spacecraft has sent warning signals to Earth again for nearly 5 decades. The spectacular Voyager space probes have explored our solar system and beyond, transmitting invaluable data back to Earth. But the probe's latest transmission has been the most shocking in the last 2 decades. NASA has officially disclosed that the Voyagers encountered an unknown force within the vast expanse of space, and the nature of this entity remains shrouded in mystery. What did the Voyagers find, and what prevented the spacecraft from transmitting this discovery immediately? Let's find out. If we make contact with them, I think in this century we will probably pick up signals from an extraterrestrial civilization. NASA's twin Voyager spacecraft have transformed into 2 incredible time capsules representing their era. These remarkable man-made space probes have boldly ventured beyond our solar system, charting new territories and delivering groundbreaking discoveries to scientists on Earth. What most people don't know is that these spacecraft have a memory capacity that is 3 million times smaller than a regular smartphone and transmit data at a rate approximately 38,000 times slower than a 5G internet connection. Still, these spacecraft, designed in the 1970s, are some of the most successful probes ever launched. In an unexpected turn of events, the Voyagers have made a recent discovery that has divided the scientific community, with many scientists hoping that the data is a result of a malfunction rather than genuine readings. The strangest part of this incident was that it appeared like the probes had to conquer an extraterrestrial force to deliver this message to Earth. Before we delve into NASA's latest findings on this incident, let's take a closer look at these spectacular probes that have tirelessly observed the cosmos on behalf of our planet. These 2 spectacular spaceships owe their launch to a rare celestial alignment, which takes place once every 176 years. In this specific instance, the 4 largest planets in our solar system played the role of the guiding stars. These planets, Jupiter, Saturn, Uranus, and Neptune, created a cosmic gravitational slingshot effect that could boost the spacecraft's speed as it passed each giant planet. It was as if the spacecraft were being tugged along by an invisible celestial rope, propelling them forward with a burst of momentum. However, this alignment presented a major limitation. It took place only once in nearly 2 centuries. This rare alignment offered a golden opportunity for interplanetary exploration. To take full advantage of this celestial event, a spacecraft had to be launched in the mid-1970s to reach these distant planets, while the planetary lineup was still in effect. NASA seized this once-in-a-lifetime chance and created 2 identical spacecraft to embark on this epic journey. In a captivating display of cosmic exploration, Voyager 2 embarked on its remarkable journey from Cape Canaveral, Florida, on August 20, 1977, propelled by the Titan IIE Centaur rocket. On September 5, 1977, Voyager 1 followed suit, embarking on a twin odyssey into the cosmos. Their primary mission was to explore the gas giants of our solar system, Jupiter and Saturn, along with the moons that encircle them. Yet these intrepid explorers far surpassed their initial objectives, embarking on a voyage that would carry them to the outermost regions of our celestial neighborhood. Voyager 1 and Voyager 2 have achieved numerous milestones during their epic journey. They've endured longer than any other spacecraft in history and ventured farther from Earth than any other human-made objects. In fact, they've crossed the threshold into interstellar space, making them the first human-created objects to achieve this feat. Their voyage into interstellar space, beyond the sun's sphere of influence and into the uncharted expanse of the galaxy, has yielded invaluable data, leaving scientists astounded. As pioneering interstellar probes over 12 billion miles from Earth, they continue to surprise physicists with their discoveries. One such astonishing discovery is the recent warning from the space probes, confirmed by NASA scientists. We'll delve into that in detail shortly. The Voyagers stand out as extraordinary space probes due to their utilization of self-powered radioisotope thermoelectric generators, RTGs. These nuclear batteries, also referred to as radioisotope power systems, employ the Seebeck effect to convert heat from decaying plutonium into electricity. Remarkably, these RTGs operate without any moving parts, minimizing the risk of wear and tear and making them exceptionally well-suited for harsh and remote environments. One notable advantage is that these generators are not dependent on solar energy, making them highly advantageous for deep space missions. However, there's a catch. As time progresses, the decaying plutonium in the RTGs gradually reduces their power output. Despite this, the overall mission has not been compromised thanks to the proactive measures taken by NASA engineers. They have strategically deactivated heaters and non-essential systems that do not impact the spacecraft's flight capabilities in order to compensate for the diminishing power supply. But the engineers' efforts don't end there. The Voyager spacecraft was designed to use a special 8-track tape system for data storage and playback. Here's how it works. First, the scientific instruments on board the Voyager probes collect various types of data, such as images, audio recordings, and measurements, and convert them into a digital format. The digital data is then serialized and stored on the 8-track tapes, which feature 8 parallel tracks for efficient storage. When it's time to transmit the data back to Earth, the onboard computer sequentially reads the data from the relevant tracks. The read data is transmitted through the spacecraft's communication system, primarily utilizing its high-gain antenna to send the information back to Earth. On Earth, receiving stations capture and decode the transmitted data, preparing it for scientific analysis. The materials used in these tapes are specially designed to withstand the rigors of space. They typically comprise a metallic base layer made of materials like stainless steel, which is resistant to radiation, extreme temperatures, and the vacuum of space. Each track on the tape is coated with a magnetic material that stores the digital data, designed to resist degradation over time. The tapes are also encased in protective enclosures to shield them from potential damage sources like micrometeoroid impacts. The enduring functionality of these tapes is remarkable. Regardless of their old-fashioned design, they continue to operate and transmit data back to Earth every day. What are the notable achievements of the Voyager spacecraft? The achievements of the Voyager twin probes have been nothing short of spectacular. Their early observations of Jupiter and Saturn's moons made over 40 years ago astonished researchers and shattered previous assumptions about these distant worlds. These moons, once thought to be as inert and heavily cratered as our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, reached several significant milestones during its journey. As these spacecraft continue their remarkable voyage, NASA has implemented a series of measures to extend their operational lifespans. Over the past 3 years, non-essential components and heaters have been turned off to conserve energy, enabling them to operate well into the next decade, with an estimated mission end date of 2030. For the scientists and engineers who have been part of this extraordinary journey since its inception, the culmination of the Voyager missions is a bittersweet moment. Their dedication and hard work have seen the project through far beyond their initial expectations. The data returned by the Voyagers has provided invaluable insights, fueled countless scientific discoveries, and inspired generations of researchers and space enthusiasts. Voyager 1 and Voyager 2 were not just ordinary spacecraft. They were meticulously designed to be stable platforms, with a rotation rate more than 15 times slower than the hour hand of a clock. This design minimized any visual blur as the spacecraft captured images and data while hurtling through space. Their impressive imaging capabilities began to astound scientists and the public even before their encounters with the outer planets. The spacecraft started transmitting images of Jupiter while still several months away from the planet. These early images, revealing the gas giant's swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly set the stage for the Voyager's groundbreaking observations. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in the solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured. These images revealed towering volcanic plumes and a surface marked by the ejection of volcanic material. Pele, one of Io's most prominent volcanoes, has erupted 30 times higher than Mount Everest, covering an area nearly the size of France. The Voyager spacecraft captured over 33,000 images of Jupiter and its moons, showcasing the planet's beauty and the incredible diversity of moonscapes in the Jovian system. Before the recent warning, The twin Voyagers have been making spectacular discoveries since their launch. One of the most surprising findings was the existence of Jupiter's rings. These rings, though faint, were a revelation and added to the intrigue of the gas giant. Additionally, Voyager 2 revealed that Europa, one of Jupiter's 53 named moons, possessed an icy shell believed to be over 60 miles thick. These findings challenged previous assumptions about the nature of these distant celestial bodies and inspired further investigations into the potential habitability of icy moons. As the Voyagers departed from Jupiter, they received a gravity assist that provided them with a farewell kick, propelling them towards Saturn. Without this vital boost, they would have been unable to escape the sun's gravitational pull and venture further into space. Voyager 1 and Voyager 2 soon went their separate ways, each heading towards new frontiers. Voyager 1's path took it close to Saturn's moon Titan, which is cloaked in an orange hazy atmosphere. This moon's mysteries piqued scientists' interest, leading to further studies of its composition and potential for prebiotic chemistry. Meanwhile, Voyager 2's journey led to another groundbreaking discovery at Saturn. The probe identified a new, distinct feature within the planet's rings, known as the spokes. These unique formations, resembling radial lines, added to the complexity of Saturn's ring system and provided new insights into the dynamics of ring particles. As the Voyagers continued their journey, they discovered the moon Titan, which is considered the closest analog to an early Earth environment. Titan's dense, nitrogen-rich atmosphere and surface lakes of liquid methane and ethane made it a compelling target for further exploration. Voyager 2, in particular, revealed the complex and dynamic nature of Saturn's rings, showcasing their intricate structures and surprising variability. This included the discovery of the F-ring, a narrow and bright ring encircling Saturn, which displayed fascinating kinks and knots, believed to be caused by the gravitational interactions with nearby moons. NASA has not dismissed the possibility that the anomalous data received from the Voyager spacecraft might have been caused by an extraterrestrial force. However, they are also considering other explanations, such as technical malfunctions or previously unknown space phenomena. As the Voyagers continue to transmit data, NASA remains vigilant, analyzing the incoming information with a critical eye. They aim to decipher the mysterious signals and understand the nature of the force that the spacecraft encountered. Scientists eagerly await further data from the Voyagers, as each transmission holds the potential to unveil new cosmic mysteries and provide invaluable insights into the universe. The journey of the Voyager spacecraft is far from over, and their continued exploration promises to deepen our understanding of the cosmos.